Hi, my name is Kenneth Wu. I'm the primary author of these studies, the role of cystic fibrosis transmembrane conductance regulator in skeletal muscle contractile function. We know that genetic mutations in cystic fibrosis result in CF transmembrane conductance regulator, CFTR protein dysfunction. We also know that CFTR protein is expressed in human skeletal muscles. There are also skeletal muscle abnormalities in people with CF, but the effect of CFTR protein dysfunction on skeletal muscle abnormalities is unknown. The objective of these studies is to investigate the role of CFTR protein in skeletal muscle contractile function. We conducted a prospective cross-sectional studies at the Toronto Adult CF Center in St. Michael's Hospital, Toronto, Canada. We've recruited 34 adults with minimal function CFTR mutations. So these are people with more severe CF phenotypes. Compare them with 18 adults with residual function CFTR mutations. These are people with milder CF phenotype. We measure the quadriceps muscle torque, bicep brachii muscle force, and handgrip force with dynamometers. We also measure the leg muscle power with stair climb power tests. The quadriceps muscle contractilities was determined by the quadriceps muscle tort, normalized the quadriceps muscle size, and the quadriceps muscle size was determined by the quadriceps muscle layer thickness and rectus femoris cross-sectional area measured with ultrasound images. We conducted multivariable regression analysis, adjusting for confounders in the statistic analysis. In conclusion, we find that people with residual function CFTR mutations have significantly higher quadriceps muscle contractilities than people with minimal function CFTR mutations. For example, when we look at the quadriceps muscle tort divided by the quadriceps muscle layer thickness, the residual group had 27.5 Newton meters per centimeters higher than the minimal group. The 95% confidence interval was between 2.2 to 52.8. When we look at the quadriceps muscle tort divided by the rectus femoris cross-sectional area, the residual group had 5.6 Newton meters per centimeter square higher than the minimal group. The 95% confidence interval was between 0.3 and 10.9. We did not find any significant differences between the two mutation groups on quadriceps muscle tort alone, leg muscle power, bicep brachii muscle force, and handgrip force. So in conclusion, CFTR proteins may play a role in skeletal muscle contractilities. In people with CF, there's a limited capacity to exert muscle force per unit of muscle size. So this suggests that in exercise prescriptions, resistance exercise focusing on muscle hypertrophy to build a greater muscle mass may improve muscle strength in people with CF. Thank you very much.